In this video, I'm going to demonstrate the quantitative problem-solving process using an average velocity type problem. So the example here I'm going to use is a car traveling along a straight level of ground here. That's straight and level. So I got my car here at the beginning point, okay? And I got my car down the road here somewhere. And I'm going to say that the car travels 50 meters. So I'll use the front of the car as a reference. The front of the car as a reference. I'm going to say that it travels 50 meters. And we're going to put brackets around our units here. Okay, 50 meters to note that distance here. And we're going to do it in time of 10 seconds. So this is going to take 10 seconds of time. Okay. And it's not so much the math here because the numbers are pretty straightforward. It's more the problem-solving process. So I want to find the average velocity. So I'm going to say V bar, the average velocity. If I don't put a bar, that's the exact or instantaneous velocity. That'll come up a little bit later. So this is the average velocity. So the equation, step one, the equation for average velocity we're going to say is the average velocity is equal to delta, it's a triangle, delta x over delta t. And delta, the Greek letter delta, means the change in. So how much it changes in distance and how much there's the change in time, the change in. Okay, so this is what we want to write down every time. Delta x over delta t for average acceleration. There should be a bar right here, average. Okay, step two is the variables. So delta v bar is going to be our average velocity. Delta x is our change in position, how far we travel horizontally. And delta t is our change in time. Okay, so those are our variables. And this arguably is the most important because if we get the correct variables here, then we have step three, which is solve, which is the mathematics of it. Okay, so the average velocity we do not know, so I'm going to put a box here stating that we do not know it. Okay, that we need to find that, and it's going to be meters per second when we're done. We're using the metric system here throughout. The change in x or delta x is 50 meters. 50 meters is our delta x, and our change in time is 10 seconds. Okay, so it's a matter of writing down the numbers from the given. Step three, solve. So now that we know what equation we're using, what the variables are, now it's a matter of plugging in the correct numbers in the equation. So this is going to be delta x over delta t, which is going to be equal to 50 divided by 10. So the math's not difficult here. It's just the process, which is going to be 5 meters per second. And we know that because this is a meter, and that's a second, so it's meters per second. Okay, we don't need to repeat the units here because we've already done it here with brackets, and then we're going to box our answer, our final answer. Okay, so this is a model of a quantitative type problem. This one involves average velocity. So again, to review, we want to make a picture out of the word problem. The problems you're going to see are going to be word problems for the most part. There might be a picture, but even then we want to denote what values we know. We want to clearly write down what we need to find. Sometimes there's more than one thing. Write down the equation that refers to that variable we want to find. The variables, the unknown and the known. So if we have an unknown, we put a box. Otherwise, we put the knowns here. And then step three is the math. Step three is if you got the right equation and right numbers, if there's an error here, it's just a mathematical error. Okay, our final answer with units, and we box our answer. So this is an example of a quantitative type problem using average velocity to demonstrate the types of problems you're going to do in the lab and in the homework.